Hi, this video is going to be to explain the hyperbola, and I'm only going to explain it and do the first two examples and then stop there because this was an optional topic for the course. Remember, juniors, next year I invite you to come back to pre-calc while I'm teaching conics so that you can learn this. I think it is important, maybe not for every single major, but I think it's interesting, and it's really the only time you get to learn this. A hyperbola is like two parabolas going in opposite directions, and there's two types. There's a hyperbola that opens left and right, and there's a hyperbola that opens up and down. So the general form from yesterday of an ellipse, you have two squared terms, x and y are both squared, and if the coefficients are different on both of those, then it's either an ellipse or a hyperbola. Now, if you have a situation where you have two squared terms like this, and the coefficient of x squared and the coefficient of y squared are exactly the same, that would be the equation of a circle. For an ellipse, though, your coefficient of x squared and your coefficient for a hyperbola, the coefficient of x squared and the coefficient of y squared have different signs, so one would be positive and one would be negative. So you would take your general form, and we're going to do this. We're going to maneuver it, we're going to complete the square, and we're going to put it into the standard form that you need to graph it. So if x squared is the positive term, then that means the number underneath x squared would be your a squared. And if x squared is the positive term, your hyperbola is going to open left and right. So it's going to be a parabola that opens to the left and a parabola that opens to the right. Both of those are considered part of the hyperbola. If y squared is the positive term, the number underneath that would be your a squared. So your a squared is going to be underneath your positive term. But if y squared is positive, when you graph your hyperbola, it's going to open up and down. It'll look like two parabolas that are going away from each other again. Okay, so the way you graph a hyperbola is you still start with your center, which is hk, just like a circle, just like on an ellipse. So if I start with my center, which is hk, again, you would use your formula in this standard form so that you could identify your h and your k. Now, whatever is underneath your positive term, again, determines how the hyperbola opens. Because x is positive, it's going to open left and right. I would take the square root of a squared and go that direction, left and right of the center. So I would go a units to the right, this would be a vertex. I would get a units to the left, this would be a vertex. And once we finish setting up our hyperbola is going to start at the vertex and look like a parabola to the right and a parabola to the left. But these vertices will be on the hyperbola. Then you take the square root of b squared, and you would go up and down the b units for your co-vertices. So the vertices are a units left and right of the center. For this one, your co-vertices are b units up and down from the center. Once you have those 4 points plotted, you actually make this into a rectangle. So with a dotted line, we're going to form a rectangle using the co-vertices and the vertices. So there's my rectangle. Then with a straight edge, you would draw in the diagonals of your rectangle. Now these are going to be the asymptotes for the hyperbola, so I'm going to draw in my diagonals. These diagonal lines are absolutely required as part of your hyperbola. And then I'm going to draw in the other diagonal of my rectangle, hitting the center, hitting the edge. So now I'm done with my setup to graph my hyperbola. And then the way you would graph a hyperbola like this, where x squared is your positive term that's going to open up left and right, is you would start at the vertices, which is included in your hyperbola, go out towards the asymptotes. Start at this vertex, go out towards the asymptotes. And the red graph is the hyperbola. Then to find where your foci are, the focus in a parabola is always inside the parabola. The foci in an ellipse are inside the ellipse, and that's true with the hyperbola also. But to find your foci, this time, the formula is just a little different than an ellipse. In an ellipse, c is equal to the square root of a squared minus b squared, but in a hyperbola, it's the square root of a squared plus b squared. So you would add these numbers that are in the denominator, you would take the square root of that, that's c, and to have your foci inside your hyperbola, you would start at the center, and for a hyperbola that looks like this, you would go c units to the right, that would be where one of your foci is. You would go c units to the left, that would be your other focus. Remember, the foci are always inside. Now, if it was a hyperbola where the positive term is underneath your y, your vertices would be up and down from the center, and your hyperbola would open up and down. But the rest of it is very similar. So I'm going to run through one example. Again, I'm not going to do all of these notes. I just wanted to introduce how to graph a hyperbola. You can certainly find more videos. You could go to Khan Academy to look for videos. I'm sure you could find other videos on YouTube that would help you how to learn how to graph a hyperbola. But our first example in our notes is x minus 2 quantity squared over 16 minus y minus 1 squared over 25 equals 1. Now, I know it's a hyperbola because x and y have different signs. X squared would be positive, y squared would be negative. Because x is my positive term, my a squared is 16. So a squared would be 16 in this case. Again, it's under the positive term, and a is going to be 4. My b squared is 25 in this case, and my b is going to be equal to 5. The center of this hyperbola is hk, so it's going to be 2, 1. Because x is the positive term, it's going to be a hyperbola that opens up left and right. So the two parabolas are going to open up to the right and open up to the left. So the way that you would graph this hyperbola, you would start at your center, positive 2, positive 1, there's your center. A is 4, so you would go 4 units to the right. That would be one of your vertices. You would go 4 units to the left. That would be your other vertex. Your vertex is always determined by the positive term. You would go 5 units up from here for your covertex. This would be a covertex. You would go 5 units down from here for your other covertex. And then what you would do is, with a straight edge, you would create a rectangle using these 4 points. Much easier to do this on actual graph paper. You draw in the diagonals of the rectangle, being sure that you hit the center. Now these are the asymptotes. These lines have to have arrows at the end. And then the hyperbola starts at the vertex. Here's one of my vertices. Goes out towards the asymptotes, like so. It would start here. It would go out towards the asymptote. I wouldn't expect you to worry this year about the equations of the asymptotes, but next year definitely I'll be teaching that for you kids who are going to come back and learn this with me next year. To find your foci, you would need to find the value of c. And again, for a hyperbola, c is equal to the square root of a squared plus b squared, a squared plus b squared. In this case, c would be equal to the square root of a squared is 16, b squared is 25, so it would be the square root of 41. I added those together. Now, the foci have to be inside my hyperbola, so one would be over here and one would be over here. So to find the coordinates of the foci, I would start with my center. The x value of the center is 2, so the coordinates of this foci is 2 plus the square root of 41 for my x value, positive 1 for my y value. And for this focus over here, the coordinates would be 2 minus the square root of 41 for my x value and positive 1 for my y value. So that's one example. I'm going to run through the next example. And then I think that if you're working through these notes and looking at these notes, you would understand how to do the rest of it. And then the end of the notes I'll talk about in just a second. So the next example, you have to first get it into the right format to graph it. So you have x squared minus 4y squared plus 24y minus 32 equals 0. So that's general form of a hyperbola. I know it's a hyperbola because x and y are both squared, and the signs on my x squared and my y squared are different. One's positive, one's negative, so it's a hyperbola. Okay, so I need to take this and put it into the format where I have a binomial divided by something, another binomial divided by something equals 1. So there's no other x term in here, so I'm just going to keep my x squared. And then I'm going to group my y terms together. Negative 4y squared plus 24y. I'm going to bring my constant to the other side, so it's going to be a positive 32. Remember, before you can complete the square, you always have to have a coefficient of positive 1. So x squared, I'm going to factor out the negative 4. This would become a positive 4y squared, or positive y squared minus 6y. I have to complete the square on that, equals 32. Okay, half of negative 6 is negative 3. Negative 3 squared is a positive 9. There's the perfect square trinomial. But I've changed the left-hand side of my equation by negative 4 times 9. I've changed it by negative 36. So I have to do the same thing on the right-hand side to keep this the same as the original. So I'll have x squared minus 4. The factored form of the perfect square trinomial is y minus 3 quantity squared, and this adds up to be a negative 4. Okay, now, this has to be a positive 1 in order for us to graph it. So I'm going to divide everything in here by a negative 4. I'm going to bring the negative up to the numerator here, so it's going to be negative x squared over 4. A negative divided by a negative makes us a positive y minus 3 squared over 1 equals a positive 1. So now I have my hyperbola in the right form to graph it. Y is squared this time, so when I go to graph my hyperbola, the hyperbola is going to open up and down. It'll be a parabola that opens up like this and down like this, because y is our positive term. Your a squared is under your positive term, so a squared is equal to 1, and a would be equal to a positive 1. And in this case, b squared is under the negative term, is 4, and b would be equal to a positive 2. The center of my hyperbola is HK. There's nothing added onto the x, so the x value is 0, and positive 3 is my center of this hyperbola. So now when I graph this, I'm going to do a really quick sketch. I'm going to start at 0, 3 for my center. Remember, y is my positive term this time, so the hyperbola is going to open up or down, so I'm going to go up 1 unit for a vertex, down 1 unit for a vertex. Those are my two vertices. For my co-vertices, I'm going to go v units in the x direction, so I go 2 units to the right, that would be a co-vertex, 2 units to the left, that would be a co-vertex. And the way you come up with those coordinates is just by reading them right off your graph paper. You make this into a rectangle. It's a smaller rectangle than the last one. You draw in the diagonals of your rectangle. Here's my diagonals. And for this hyperbola, because y was the positive term, it's going to open up and down. So you start at this vertex, you go towards that asymptote. You start at this vertex and go towards that asymptote. You start down here, you go towards the asymptote and out towards the asymptote. So the red marker in here is actually the graph of the hyperbola. To find where your foci are in this case, your foci would be up and down from the center because they're always inside the conic. So C is equal to, for a hyperbola, the square root of a squared plus b squared. A squared is 1, b squared is 4. So C would be equal to the square root of 5. And in order to find the coordinates of my foci, one focus would be here, one focus would be here. They're always inside the conic. This time I would have to add that onto my y value of my center. So the coordinates of the foci, the two different foci, both of them would have an x value of 0. That wouldn't change. But with the y value of 3, I would have to add and subtract the square root of 5, and those would give me the two coordinates of my foci. And don't worry about the equations of the asymptotes. So I'm going to stop with that example. If you go to the last page of the notes, and don't worry about the eccentricity either with an ellipse. I'll go into that more next year for you juniors who want to come back and learn about conics. But the last section is identifying conics by general form. So I'm not going to write that, but I want you to just look at it in your notes. So if your conic in general form only has one squared term, either x is squared or y is squared, but not both, then it's a hyperbola, a parabola. If x is the squared term on the parabola either opens up or down, and if y is the squared term, the parabola opens left or right. But for the rest of your conics, circle, ellipses, and hyperbolas, x and y would both be squared, and the way you tell what type of conic it is, if x and y are both squared and the coefficient of x squared and y squared are exactly the same number, it's a circle. If x and y are both squared and the coefficient of x squared and y squared are both positive, they have the same sign, then it's an ellipse. And if an x and y are both squared and the coefficient of x squared and y squared have different signs, one's positive and one's negative, then it's a hyperbola. So I'm going to end with that for all the conics notes. There is one more day of conics review that if you've been paying attention and you've been trying this, I think you would understand the review. There's a lot of completing the square and getting things into the right format, but you should understand that from all the other algebra we've been doing with that this year. So that'll be the end of this for this week. And then next week, we're going to start grading again. We're going to start the 4th marking period. I hope you're all doing well, and I'll see you next week.